Section 5.2 introduces the concept of similarity, and it's really the introduction so that we can get ready to seeing that polygons are similar, triangles are similar. And the word similar is represented with the tilde symbol, and it means same shape. Now let's remember congruent means same shape and size. Are two triangles or two quadrilaterals or two pentagons have the same shape and the same size if they're congruent. If they are similar, they have the same shape, but they are not the same size. One is an enlargement of the other. So if I have this pentagon, and then I have this pentagon, they're the same shape, but they are obviously not the same size. They would be considered similar. So for polynomials to be congruent, they have the same angle measurements. To be considered congruent, they would also have the same side lengths. That is not true. They do not have the same side lengths to be similar. We're going to find out their side lengths are in proportion. So here I have two congruent triangles, same shape and same size. If two polygons are congruent, they are also similar. If they're the same shape and size, they are the same shape. It's less restrictive to be similar. So as an example here, they have cans of frozen orange juice to show that similar means same shape. Here's the smaller number of ounces. This is 8 ounces, this is 16 ounces, but they're the exact same shape, but they are not the same size. And here's a can of tuna. This is not similar because this isn't the same shape. This has different dimensions altogether. So even though all three of these are cylinders, right cylinders, only the two orange juice cans are considered similar because they're the same shape, even though they're not the same size. So we're going to assume that when we're talking about polygons, we're talking about polygons in a single plane on a single piece of paper. So for polygons to be similar, it's necessary that each angle of one polygon is congruent with its corresponding angle in the other. So angles are congruent. Now that's not going to be enough to make them similar, but that is one requirement. That's the first condition. And angles are represented by points which are vertices. So we're going to have corresponding parts between these similar polygons. So if I have that angle A in polygon 1 is congruent to angle H in the second, the way we're going to write that here, I think it's just easier to draw it out. If this is A, B, C, D, E, this pentagon, there you go. And let's say this is X, Y, Z, T, R. We would say that angle A corresponds to angle X. All right, or we could just say vertex A corresponds to vertex X. So that double arrow, that's going to be our corresponding symbol. And so we would say angle D corresponds to angle T, or vertex D corresponds to vertex T. And we want to make sure that all the corresponding angles are congruent. So here's our example. These are similar quadrilaterals. So these have single ticks, so we would say A corresponds to H. vertex A corresponds to vertex H. This one has 2 ticks. So we would say vertex B corresponds to vertex J. The same for vertex C, going to the 3 arc angle, and vertex D corresponds to vertex L. And you could name them the vertex or you could name them the angle. Angle A corresponds to angle H. Whether you're just naming the name of the point, the vertex, or if you're naming the angle, they're going to correspond. Now, not only do angles correspond, but sides correspond. So between the 1 and the 4 arc, side AD corresponds to side HL. Side DC corresponds to side LK. We just keep going. Side BC corresponds to side JK. B corresponds to J, so J's got to be the first letter in that segment. And then if we have AB, segment AB is going to correspond to segment HJ. So that's what they wanted us to do, name all the vertices, angles, and sides that correspond to each other. So here are the 2 conditions for 2 objects to be considered similar. 2 polygons are similar if and only if all pairs of corresponding angles are congruent, all pairs of corresponding sides are proportional. Proportional. So we're going to have to prove that the proportion from one side to another is consistent across both shapes. So the second condition for similarity said that the sides have to be proportional. So that means side AB in the diagram that I had, side AB to side HJ has to be the same proportion. Side AB to its corresponding side HJ have to be in the same proportion as side BC to side JK has to be in the same proportion. All of the corresponding sides have to be proportional, and we're going to do a lot of work in that in the next section. Both conditions have to be true. Condition 1 said that all the angles have to be congruent. And here I have 2 polynomials. And you know what? All of the corresponding angles are congruent. But are those 2 shapes, are those 2 figures the same shape? No, they're not. So condition 1 is not enough to show that polygons are similar. And here's condition 2. Condition 2 said the side lengths have to be in the same proportion. And so if these are all the same size and these are all the same size, these proportions are all going to be the same. So here is an example of a square and a rhombus. The sides are proportional. However, are those 2 shapes the same shape? No, they are not. So not only do the angles have to be congruent, the sides have to be in proportion. Both conditions have to be true. for polygons to be considered similar.